And with
Next
that
up.
note, I'd like to welcome our next speaker to the observability track. It is Mr. Mohammed Qudrath. I do horribly apologize if I heard your surname there. And Mohammed will be talking today about operational visibility in distributed systems. And this is quite a key topic for a lot of people within the observability world. And without going into too much detail, I'll just leave a quick note and do some housekeeping, and then I will hand over to you, Mohammed.
Sure, sir.
So with that, please remember we do have a COC today. And for all our conferences, my lovely co-host Sebi will be dropping the link in the channel there. So pretty simply, play nice with others, and if you don't, somebody's going to come have a chat with you. I'd also like to just thank our sponsors, the lovely teams at Teleport, Blameless, Cortex, Stormforge, Shoreline, Lightstep, Fire Hydrant, and PagerDuty. And lastly, Ridley. And without much further ado, I will hand over to you, Mohammed.
Yep. Just get this, and here we go. Awesome. Thanks, Chad. And I just want to thank everyone over here. Let me just this back again. And thanks to Container Solutions for hosting WTF as SRE. I think it's pretty awesome to have a session like this where we are able to share about our different approaches to getting started with SRE in general. So just as an intro, I'm Faz. So short for Mohammed Fazalullah Qudrath. So I'm a senior developer advocate at Amazon Web Services. And today's session is actually going to be a lot on best practices and how you want to get started with getting operational visibility through instrumentation. And this is important because a lot of folks, they dive into observability trying to get into what tools to use, what libraries and frameworks to use, without trying to understand how you would want to approach the whole idea of instrumentation. So we're going to cover a bit of that. We'll cover what you want to measure, what you want to actually look at measuring, what are the best practices you want to do while logging, and a very special case on high throughput services where you're suddenly having a service which is having massive amount of requests coming in, huge volumes of logs. How do you handle that? And a quick deep dive into some AWS services that would allow you to get that started with managed services, and then some resources for you to get started with immediately after that. So to set the stage for today's session, here we have Werner Vogels, VP and CTO of Amazon.com. He's someone who's pretty prominent in the resilience space. He talks a lot in his keynotes about failure and how to design with failure in mind, right? Even if you're running something on the cloud, the idea is that you want to make sure that your applications and services are still resilient. They're able to run even if there is certain failure somewhere. And one of the ways you want to do this is by having a very cohesive and a very holistic approach to observability on your systems that you're hosting, wherever you're hosting them. So you want to start looking at monitoring and then observability and how you actually get logs through instrumentation and other things as a key part of understanding how to handle failures in scenarios like this. So to get some definitions out of the way quickly, observability is basically a measure of how well internal states of a system can be inferred from knowledge of its external output. So you look at it as a black box, and then afterwards you see by what the external outputs are, and then decide, okay, this is the behavior of the actual system that's currently in play and being observed. And from a monitoring perspective, you're telling whether a system is actually working or whether it's not working, right? Observability is kind of like understanding why it is working or it isn't working. So in a way, good observability allows you to answer these questions you didn't know and you needed to ask. So think of observability, especially a good strategy behind observability, as a way to get trends, a way to get insights more into system behavior, which you may have not even anticipated before it actually went into production, or maybe after a certain amount of time it's been in production. And just to be clear, right, observability is much more than just monitoring failures, right? You're also looking at behavior, right? You're asking questions like, okay, is this behavior expected or not? And what is the actual usage of the application or the service that's being made, whether it's from a human user or whether it's from other services, right? Other machines. And what is the actual business impact? Because in the end, whatever products and services you build and you're building observability around that, this is going to have someone on the other side who's actually going to be using. It will have some impact on your business and also maybe on the business of the users who are using these services, especially if it's a B2B case. So you want to make sure that you're covering a lot of these questions also as part of your observability strategy. And as an example of what it looks like, if you like, let's say, take the Amazon.com page and something's gone wrong when you're placing an order or looking at details of an item page, what monitoring would look like is when you get an error, like user saw 503 error, right? That's monitoring. It's something that's happened in the past. Versus observability, where you have three things, which we'll be talking a bit more. These are basically what you call as signals in the observability space. So you have metrics, like what browser agents connected to my page, where was the user connecting from, the IP address, if any, what's the geo region, stuff like that, which user saw the 503 errors. From a logs perspective, okay, so-and-so area, so-and-so API actually was connecting with a credit card company, perhaps behind the scenes, right, when doing a payment. Then from a traces perspective is end-to-end, how long did it take to connect with the credit card company once a request was placed from the user side? And then who else are we trying to send traffic to behind the scenes? Now, traditionally, with monitoring, if you go back years, where especially I started in IT like almost like 16, 17 years ago, our application stack at that time was pretty straightforward, right? It was a monolith. You had 3-tier web applications. And with traditional monitoring, you would have that application, and then you would have a number of layers in the stack you would have to monitor yourself. So from the network storage to the physical server hardware, all the way to many abstraction layers. Over the years, virtualization became the norm. And you would then also have to instrument some form of the application itself to get some logs out, right, to get an understanding of what's happening. Now, in the last 10, 15 years, that stack has changed and it's evolved, especially when it comes to microservices, or maybe services that are being deployed on containers, for example. And you now have an application container, you have a container runtime, you have maybe a container orchestrator like Kubernetes, and then everything else under the hood, right? So now you're having all these different services that are running under the hood to serve that one request that your user is looking for. And you want to make sure that you're able to get some meaningful insight out of this whole system. Because it's not just about, okay, each disparate system trying to do exactly what it's trying to do. You're also trying to understand what's the business impact in the end for the actual user who's going to be using the system. So for observability, if you go back to theory of control systems, a system is basically observable if the behavior of the entire system can be determined only by looking at its inputs and outputs. So you look at it as a black box, and then you see, okay, this is what's going in, this is what's coming out, this is how the system actually behaves. That's kind of like how you do it. And the way you want to look at observability is by looking at different signals that you have in services or applications that you're deploying. So there are three kinds of signals that you would primarily want to look at. The first one is metrics, the second one is logs, and the third one is traces. So with metrics, you're looking at gathering a lot of numerical data, right? Things like, okay, maybe so-and-so from so-and-so IP address, for example, or maybe from so-and-so order for so-and-so number for so-and-so product, for example. This is all different numbers you're trying to gather. Beyond that, also from a request perspective, what's the request rate, the error rate, and what are other business metrics that you would want to capture in terms of orders placed, payments received. Then you have the logs. And these are basically time-stamped records of events. So something is happening, a failure, maybe an error, or maybe something just informational, right? An order has been placed, for example, which results in a state change behind the scenes on the data store which you're using. So logs usually would have metrics also included in them. So you would have like maybe a number of products that's being ordered at the same time as a number. Then you have the traces, which is basically an end-to-end single user or transaction journey, right, through a number of separate applications. A trace kind of allows you to see the journey of the user and when they're placing the order to all the different systems that are being impacted through that actual order, for example. And this is something in the current space in logging and monitoring, and now with observability, we're seeing a lot of development happening with different providers, partners, for example, on AWS, who are providing different features on their applications, which allow you to have visibility on distributed systems on a single pane by just logging in and then trying to figure out, okay, when so-and-so requests originate from this point, what actually is happening beyond that. So to give an example, if I'm alerted on a metric, I should be able to see the associated logs and traces with a few clicks and easily navigate between the different components of my application. As someone, maybe as a developer, or as someone who's a DevOps practitioner, or someone who's an SRE, ensuring that things are running fine, if I can do that, I spend less time working out what's actually wrong, and then I have more time fixing the actual problem. So with anything in terms of signals, for example, you will have a life cycle, right? A journey from how it gets started and then what you would want to do with that. So the life cycle of a signal actually starts from instrumentation. So you write code, and then afterwards you write a way to generate that signal in your application. Then you want to capture that signal, and then obviously once you capture it, you want to also transport it somewhere, right? Especially if it's like a container or a VM, you want to get that signal out of the container or VM. And the other side is if you're using managed services, like for example, you're using a serverless service like AWS Lambda, which is functions as a service, you get that out of the box, where the signal, if you're writing logs, for example, that gets transported directly to a service like CloudWatch, where you can look at the metrics and the logs directly. Next, you want to analyze and use these signals to observe what's happening in the system, so that you can get to the issue or understand how the system works. And then once you have that, you want to actually act upon it. So some of the ways you will get started with this is that you will have a language-specific SDK for instrumentation and capturing. Like maybe you use the AWS SDK if you're using Python, like Boto 3, and then you directly write your log or metric to a service like CloudWatch. Or you would have an agent that is running in along with your service, which is capturing the logs directly from a log file, and then afterwards transporting it across using maybe a collection agent, for example. And once all of these logs and these metrics are all captured, they come in, and then afterwards you analyze them visually, maybe through a dashboard. And because you have someone who's monitoring the dashboard, or maybe you have some kind of automation behind the scenes, you may set up something like alerts and then mechanisms to send notifications and then act on what should happen next because something has got triggered in your system. So we'll have a look at instrumentation, and I'll be focusing a bit on how we do it at Amazon. So a lot of this is on how we currently develop our systems. So you may take whatever you need from this and just understand every person and every organization has different needs. So some of the things are pretty basic and fundamental. Like you want to look at instrumentation as a lens to understand how your system's actually working. And in our case, Amazon is primarily built as a service-oriented architecture, right? So you look at Amazon.com, there's a lot of talks we've shared in public about the architecture in general. And we talk a lot about how these services collaborate with each other to get something up and running, right? So like rendering a web page on Amazon.com. And as a result, you also start seeing that because you have all these services running, you get an increase in the latency of service deep calls in the chain, right? So for example, you have like a call which is just to place an order, but behind the scenes you may be calling another 10 systems and services. So any latency behind the scenes on even one service kind of has a big ripple effect on the actual flow of the placing the order for the user. So instrumentation enables us to detect and respond to operations, especially from a tactical level. And what we do then is we use instrumentation and then afterwards get that data and feed that into operational dashboards so that operators or service owners, in this case, would view real-time metrics. And you would also have this feed going into alarms which trigger and engage operators when the system is behaving in an unexpected way, like we saw in the life cycle just before. Now, to understand what to measure, you want to like start looking at operating services when you're doing it from a high standards perspective, right? So you have different standards. You'll have it from an organization level or an SLA level that you have with other users. So you want to make sure that you know how to measure the system, right? So that you know exactly how it behaves. So as a service owner, I need to measure system behavior. You need to make sure that you have a request flow through a distributed system. You're able to visualize it in some form or the other. And you have one place where you can put together all these different measurements and maybe even alarms and anything else that you need on top of that. Now, one of the ways you do that is by instrumenting each service call with a, or at least each unit of work with a trace ID. So you want to make sure that you propagate this trace ID from the beginning of a request to all the other services collaborating on the task. And then you collect the instrumentation across the systems for this given trace ID in a tool which you choose. For example, maybe you would be using CloudWatch or maybe using Elasticsearch or OpenSearch, and then you would just use your trace ID to find out, okay, I know this is the request, this is the trace ID, what's all the different services that have been impacted through that. And you would maybe also just use it as a way to visualize it from your graph itself. Maybe using something like AWS X-Ray, which we'll talk a little bit into towards the end. So service owners need to measure the operational performance from multiple places to get multiple perspectives and how things are behaving end to end. And to just give you an example, right, just to understand what to measure, you are basically trying to ask different questions from your service, right? What are the kind of things you want to observe from it? So to give you an example, if we implemented a service API operation that retrieved product information by product ID, the code might look something like this in this case. And the code looks up product info in a local cache, followed by a remote cache, and followed by a database after that. So if I were operating this service, I'd need a lot of instrumentation in this code to be able to understand its behavior. Because if you notice, there's a lot of calls happening to other services in this case. I need to be able to troubleshoot a field or slow requests and monitor for trends and signs that different dependencies are underscale or misbehaving. So here's different questions that you would want to ask, and then you would add code accordingly for instrumentation, right? So from things like, okay, what are the different products that we're looking up, and who called the API, right? What is the origin of the API? Did you actually find the item in the local cache, for example, or was the item in the remote cache in this case? How long did it take to read from the remote cache, and how long did it take to deserialize it? Also, you need to understand, okay, from a caching strategy, you want to make sure that how full is the cache, right? You want to make sure that are you able to like visualize, or at least figure out, okay, are you hitting a memory limit in memory, for example, for holding the cache in the system. Beyond that, when you start looking at doing database queries, you want to like instrument and get data on how long the database query is actually taking. Did the query actually succeed? And if it failed, how long has it taken? I mean, why was the timeout actually happening? Then beyond that, once you actually fetch the data, you want to then populate it in the cache, and then you want to see, okay, how long is it actually taking to do this? And in the end, the actual product info that you're getting back, how big was it, so that you can figure out, and then afterwards scale your systems better in that. Now, with knowing what to measure, one of the things you want to look at is how all of these things layer. Right? You have the three signals, you have logs and metrics, and then afterwards you have traces. You want to get started with, you reach a point with the kind of instrumentation you do in the observability strategy you implement, that you get aggregation of all of these metrics that trigger alarms and then display on dashboards. And then you ask questions on why an anomaly is actually happening, right? And because you are looking at that, you may actually start drilling down into the trace, right? You try to get an understanding of what exactly is happening behind the scenes. And then once you get to the trace, and then you see, okay, and the metrics, you see that it's not enough, the kind of information you need, that's when you actually dive into the raw detailed log data, right? You actually go into the you go into your aggregator where you're collecting all these logs. You have the raw logs over there. You do queries on top of that. So as much as possible, you're trying to make sure that, okay, you're at a high level able to maintain operational visibility. You're able to ensure your systems are working fine, and then you dive deep as and when you need to, versus doing it always in this case. So from an instrumentation perspective, you want to make sure that you're writing code in a way where you can actually generate these logs and metrics, right? You would use different libraries and frameworks in this case, but ideally what you want to look at is you want to adopt some common patterns. So two ways you want to look at this is standardization for common instrumentation libraries. So to give you an example, maybe there is an industry standard for the kind of logs you're trying to generate, or maybe it's a community practice, for example, or maybe it's within the organization, something that's being set by your DevOps team, or even your DevSecOps team, right? They may have a certain audit policy where they say, okay, every log that we generate has to be done in this way. So you would use an instrumentation library that actually generates that. Then you want to look at some form of a standardization across metric reporting, right? And this is where structured logs kind of start coming in. You want to start looking at this data with a structured log file. So emitted as one log entry per unit of work. And just as an example, what you want to look at is how you would differentiate between these logs. One thing to understand is at Amazon, and again, this would differ from different organizations, we log first everything that we do, and then we produce the aggregate metrics later, because we want to make sure that we have access to the log files so that we can debug them later if needed when there are customer issues. Three usual logs you will actually look out for in the standard when anyone gets started in programming is that they would start with an unstructured log where they print, okay, XYZ is happening with so-and-so metrics. Then you would start creating some form of structure around it, right? There are different forms you would do a structure. Some people add key value into the log message, and some folks actually write a JSON object around that. So you could then use your query tools accordingly, and then afterwards query the log entries in this case. So over here right now we have like, if you go like fully structured, you could actually create a JSON object, have different keys, which you can then query in something like CloudWatch logs, right? And then afterwards figure out, okay, how things are working out, and then even use that on a dashboard afterwards for visualization. So instrument services, you would want to instrument them to emit two kinds of log data in this case. So the first one is for request data, which is basically any request that's coming in from an external system or from a client service or anything else. And the other one is debugging data in this case. So request log data is a single structured log entry for each unit of work. And then you want to make sure that this is basically from the beginning, right? From the front door of where the system is actually getting started. Then you have debugging data that includes unstructured debugging lines emitted. And you want to consider detailed logs as much as possible when you have to investigate availability blips, latency spikes, and customer-related problems. But to understand this thing with detailed logs, what usually happens is there is a trade-off, right? There's storage costs that you need to keep. So just keep that in mind when you're considering detailed logs. Of course, storage costs, as and when we keep going ahead, storage costs are always reducing. So it's always good to have detailed logs as much as possible. I'll quickly go through log best practices, also being mindful of time, just to give you an idea. And I have resources at the end that you can actually go through yourself later and understand how things work. So some of the things you want to look at is you want to emit one request log entry for every unit of work. So in this case, you write one log entry for each request that a service receives. You don't want to compile multiple units of work together because each unit of work is usually in isolation anyway. Then you want to request a log entry for a given request. So don't emit more than one, right? And this is especially useful in a non-blocking service implementation, where it might seem convenient to emit a separate log entry for each stage in a processing pipeline. But what makes sense is actually to create maybe something like a metrics object, right? Which you can then take and then see all the different stages that it's gone through in the service. But on the flip side, for example, if you have like a long-running multiple minute or multiple hour workflow, it makes sense to break these tasks into multiple log entries because you may need to determine whether progress is being made or not. Then try to, as much as possible, record these details for troubleshooting before things like validation, where maybe in validation something fails and then it goes out. You want to make sure that you're able to capture all the request data if needed. And also make sure that you're able to sanitize the input in this case when like encoding, escaping, or truncating it before you log it. Then as a way to have increased verbosity in your logs, try to have that option available where you're having different levels of logs, severity of logs that are there, which you can then switch based on your tool which you're using for viewing the logs, and then you can query those logs accordingly. That way, then you just go deeper into more detailed logs as and when you need to. With this, and this is mostly from a max throughput perspective, is that you need to ensure that log volumes are big enough to handle, right? So you want to load test your services when you're generating maximum amount of logs. So that way, then you know how your system is holding when all these requests are coming in, and whether the log files are actually being generated or not, or whether you're, and then you'll also be able to handle, and this depends on the behavior you want for the service, whether it should stop working on, should the service stop working if it stops generating logs, or should it just generate an alarm and then you continue just rotating the logs and then continuing to override them if you're not able to ship them out in time. So one thing you need to check in that. So as a correlation to that, you want to also like consider the behavior of the system when disks fill up with the logs, right? Usually you would use rotation of logs, but then at the same time, you want to make sure that before a log is fully rotated and then you reach back to point zero again, those logs are already shipped out to your aggregator. So from a log best practice perspective, like I mentioned earlier about trace IDs, you want to use this as a way to propagate it and then move it across your backend calls as much as possible. And then use a service like X-Ray in this case, or any other service that you would want to use for visualizing all this across a trace. Then you want to also log availability and latency of all dependencies. And this is usually downstream dependencies, whether it's internal or whether it's a third party. You want to make sure that you want to log certain things like why the request was slow or why the request actually failed in this case. Then sometimes you may have like certain errors happening, recurring again and again. Look at adding an additional counter for every error reason. This kind of helps you, especially to understand trends in certain errors that are recurring in the system. Then you want to make sure that for every reason, So you also want to make sure that for organizing errors, you have a category of cause, right? So this could be like things like a category by client's fault versus category of server's fault. And then afterwards, you can then figure out and then understand, okay, where you should be debugging next the systems based on that category. as part of the unit of work, maybe there's other metadata that you would also want to look at logging. Especially when you use a structured metric log, it makes a lot of sense to add some certain metadata inside, so that you can determine who the request was from, and then where it came from, and any other things that you need to debug better. And also make sure that you're having access control and encryption on the logs. You will usually see with service teams that, especially sensitive services which handle payments, for example, they will ensure that they have some form of access control over there. So not every other team in the organization will be able to access those logs. And with an application, from an application logging best practice perspective, you want to make sure that the request ID is always there along with the trace ID. Make sure that there is a rate limit on the application logs error spam, because this usually happens when you're having high throughput services, and you want to make sure that you're able to guard this in some form or the other through the logger itself, and something maybe you can switch on and switch off. Then you want to make sure that you log request IDs from failed service calls also. So if a service is called and returns an error, the service is likely returning a request ID. So what we have found usually in Amazon is that we find it very useful to include the request ID in our log, so that if we need to follow up with the service owner, especially if it's downstream, we have a way for them to easily find their corresponding service log entries in this case. Right. I'll quickly go through this. So from an observability tools perspective in AWS, you would look at having a single platform across applications and infrastructures. So in this case, you would start looking at different services that you would want to use as a way to collect and access the data, and then also visualize trends and generate insights. This is an approach where you would want to look at whether you're using different services within AWS. So you have the infrastructure side where you would use VMs and containers, and maybe from an AWS native perspective, you would just go with CloudWatch in this case, right? So it's native observability. All the services, they will generate some form of logs, which would then go into CloudWatch, which you can then combine with things like X-Ray and Code Guru, especially if your code is there for analysis and then understanding what's the performance and best approach for writing certain aspects of the code. Then there are also other open source services that are available that you want to look at, or also work with partners, because we have a lot of technology partners that have certain services that you would want to use in this case. So three things, and what I would just quickly go through before ending with the resources is that you want to look at CloudWatch logs insights in AWS as a way to search and analyze the data, and then afterwards write queries, and also use this as a way to pump data into your dashboards. In this case, dashboards would look something like this in this case, right? So where you have different dashboards that are being fed by data from different queries that you've written beyond that in CloudWatch. Then from a tracing perspective, you would look at a service like X-Ray, which basically helps you to analyze and debug production and distributed applications. So it provides an end-to-end cross-service view of requests made to your application, and gives you an application-centric view of requests flowing. So use this as a way to dive deeper into the code and then understand how it's going. So you would use the SDK in this case to instrument the code, and then afterwards the traces then get generated beyond that. So with that, I'll quickly close on this side of things. One of the things you want to see is from monitoring and observability in general is that the question, the main focus is you're trying to improve operations. So you want to have the right questions that you're asking, like we saw in the beginning, and then afterwards instrument your code accordingly, gather the logs and metrics, and then afterwards generate alarms and dashboards, get insights, so that you can ask further questions on your systems, and then afterwards continue observing your system and helping it grow, and helping your users also to go along on that journey. So that's kind of like how you would want to use as a way to drive decisions using data. That's the approach you would want to do with the logs, metrics, and traces. In resources in general, what I would really suggest is that we have an awesome article that's been written by, it's part of a builder's library that covers some of what I've already captured, but goes more in detail on instrumenting distributed systems for visibility. And you also would want to look at certain videos. I can share these links later on the chat if needed also, where you would look at how you would want to look at data and how you would want to investigate anomalies. And also David Janicek, who's actually written the Builders Library article, he's also done a couple of talks. One of them is on monitoring production services at Amazon, and he goes in depth into the kind of approach we do. What are the different errors, and what are the different types of errors we actually pick, and then have to choose to act upon. So, a really good way to actually understand the kind of scale at which we work with logs. We also have a workshop if you're interested in running this on your own in your account, or maybe if you have contact with an AWS account team, you can point them to this and then help them get them to run this for you, where you can actually run all these different tools and services behind the scenes in AWS. Last, there is also if you're in the serverless space and you're actually writing a lot of observability, you're trying to build observability around your serverless applications, I would suggest to go through this learning path by Julian Wood, who's also a senior developer advocate on mastering serverless. This is pretty prominent. He's done a couple of sessions on this separately. There are videos also on this. He kind of dives deep into the different tools you can use and the services you can use when you're actually writing serverless code behind the scenes to handle this. So with that, I'd like to thank you for your time on this. I hope some of these things actually help you to understand how you would get started with building visibility, especially with logging and other things. So thanks for that.
Thank you, Mohammed. Overall, it was a great walkthrough in the observability area. We don't have any questions for you, but our audience is asking if you're planning to share your slides.
Sure, I can do that. Yep.
Okay, maybe you can drop your Twitter handle somewhere so people could actually get the slides from you. This was our fourth talk on the observability track on what the fuck is SRE 2022. We'll have a break now, but please be quick to jump on track 1 because we have a quiz there, and the winner will be getting the exclusive swag bag with the event t-shirt, socks, and all the stickers. And I'd like to thank our sponsors, Blameless, Stormforge, Teleport, Cortex, Shoreline, Lightstep, PagerDuty, Fire Hydrant, and Rootly. So yeah, don't hang around here too long, and we'll see you after the break.